Today you are going to be looking at learning target 4B, identifying and applying the intercepts of a linear function. Please jot down this picture so that you have an idea of where on a graph we can find the x-intercept and where on a graph we can find the y-intercept. The x-intercept of a linear function is the value of x when y equals 0 in an equation. It is the point where the graph crosses the x-axis. So in the graph on the right here, we look at where it crosses the x-axis down here at 8, and so we know our x-intercept is 8, 0, because we plugged in 0 for y. The y-intercept is the value of y when x equals 0 in an equation. It is the point where the graph crosses the y-axis. Okay, so if we look on our graph, and we look up where it crosses the y-axis here at 6, we know our y-intercept is 0, 6, because we plugged in 0 in the x spot. Making sure you write your intercepts as coordinate points is valuable at all times, because we always want to know whether we're talking about a y-intercept, like this one here of 6, or an x-intercept, like this one here of 8. Now you try. Use the graph to answer the following questions. What is the x-intercept of the linear equation to the right, and what is the y-intercept of the linear equation to the right? Go ahead and take a minute, pause the video, see if you can identify them, and then hit play when you're ready to see the answers on the next slide. Here we see that our x-intercept is 5, 0. We look down at our graph and it crosses at 5. And our y-intercept is 0, 2, right here, where it crosses on the y-axis. They're pretty easy to identify and pretty quick once you get the hang of what you're looking for. The next piece we want to talk about is how do we calculate the x-intercept in an equation. To do this, we have to plug in 0 for y. So if we had the equation 12x plus 4y equals 36, we start by writing out our equation, and we substitute 0 in where we see y. So it would read 12x plus 4 times 0 equals 36. Well, 4 times 0 is 0, so that goes away. We cancel that out. Then we have the equation 12x equals 36, which is just a one-step equation that we solve by dividing by 12. Since it's 12 times x, to undo multiplication, we divide. So divide by 12 on both sides and get x equals 3, leaving us with our x-intercept of 3, 0. Similarly, when we want to calculate the y-intercept from an equation, we have to plug in 0 for x. So if you want to find the x-intercept, you plug in 0 for y. If you want to find the y-intercept, you plug in 0 for x. We're trying to get rid of that other variable. So here we write out our equation 12 times 0, because we're plugging in 0 for x, plus 4y equals 36. Well, 12 times 0 is 0, just like anything times 0 is 0, so they'll always cancel. And we get 4y equals 36. Again, 4 times y is multiplication, so to undo that, we divide by 4 on both sides, giving us y equals 9. Therefore, we know our y-intercept is the point 0, 9. Now you try. Calculate the x and y-intercept of the following equation. 5x minus 10y equals 20. Go ahead and pause the video, look back at your notes at the last example, and take a minute and try to do this same process but with this new equation. When you're ready to see the answer, go ahead and hit play. Here we can see that to find our x-intercept, 5x minus 10 times 0, we're plugging in 0 for y, equals 20. We get a multiplication equation, 5 times x equals 20, so to undo that, we divide by 5 on both sides and get x equals 4, which leads us to our x-intercept of 4, 0. For our y-intercept, we plug in 0 for x, so 5 times 0 minus 10y equals 20. So we get the equation negative 10y equals 20, which is, again, we solve by division, so we divide by negative 10 on both sides and get y equals negative 2 to give us our y-intercept of 0, negative 2. We will practice this more in class, so if it's not completely clear to you right now, that's okay. You'll have a chance to do this later on. The last piece we want to talk about when we say we want to identify and apply the intercepts of a linear function is we want to know what they mean to us. So in this story problem it says, Ricky was going to the store to buy chips and candy. Each bag of chips cost $3 and each bag of candy cost $5. Ricky can only spend $30 at the store. The situation can be modeled by the linear equation 3x plus 5y equals 30, where x is the number of bags of chips that Ricky will buy and y is the number of bags of candy that Ricky will buy. This equation can be matched to the graph on the right down here. We have two questions to ask you. The first one is, what is the x-intercept and what does it represent in this situation? And the second one is, what is the y-intercept and what does it represent in this situation? So you have to think of, what are our variables, what do they mean to us? Go ahead and take a minute, pause the video, identify the x and y-intercept, and see if you can tell us what they actually stand for. When you're ready to see the answer, go ahead and hit play on the next slide. Here we can see that our x-intercept is at 10, 0 out here. What it represents is that Ricky is buying 10 bags of chips and no bags of candy. Our y-intercept is at 0, 6, and it represents Ricky buying 6 bags of candy and 0 bags of chips. You always look and say, okay, it's at 10, this is 10 bags of chips, and we know we plugged in 0 for y, so there was 0 of the other variable. Conversely, if we look up, we say it's 6, this is 6 bags of candy, and we plugged in 0 for the other variable, so it's 6 bags of candy and 0 bags of chips. You'll want to take a look at this. Make sure you have this example down because we're going to try these in class coming up. Make sure you have these notes and be prepared to practice in class on Monday. Have a great weekend, guys.